Okay.
Does it work?
Sounds like should be working now.
Yeah.
Let's see if we're still online.
Does it work?
Okay, it's working. Yes. So,
okay.
As I was saying, I started in last episode by discussing XSS because, it's the most widespread vulnerability in the web. And I started by showing how manual escaping is not a good idea. And even automatic escaping that is not contextual is not really a good idea. And then I showed how even advanced templating engine can still leave some blind spots. Like, for example, if you use the template engine everywhere, but sometimes someone writes to the output in a raw way. So at one point, someone might wonder, what can I do if everything else fails? So what could I do if there is no good way to make sure that my application is safe? And this is where I left on CSP. So would you like to introduce us to what CSP is?
Sure, absolutely. So content security policy or CSP in short is web mitigation technique. It's a header. It is a response header that basically limits or restricts what web page can embed. So it governs resources. So it can be scripts, it can be style sheets, it can be fonts, and many others. Like it can govern, for example, post message, XHR, fetch, things like that. So basically a document that is loaded with this HTTP response header, or if put in the meta tag, which is another way of putting it, basically it's somehow restricted, right? You can use CSP many ways for doing many things, but we believe that the most useful one is against cross-site scripting.
Yeah, basically CSP has many things, and both Miki and I worked on CSP. We invested a lot of our time in trying to use it the best way possible. And we think that the best way possible is to use it against XSS. And CSP has so many capabilities. I've seen people using CSP to try too many capabilities. Yes, I think that's one of the problems. And I've seen many people trying to restrict fonts or images that gets loaded by a site. And yes, that is kind of a problem if someone can somehow embed an image that you don't expect in your site. But I think that the best value you get is from XSS protection. So let's take a look at how this looks like. So this is what a strict CSP look like. This is basically my attempt to try to put everything in one slide. So if you have to have one takeaway from this stream, should probably be this. I linked in the title a page that details on what this is about, and now we are going to discuss what this really is. Basically, we have 4 directives here, and we will start from the first one, object source none. Miki, would you like to talk about Flash and how beautiful that is?
Yeah, absolutely. It's so fun, right? So luckily, all major browsers got rid of Flash will get rid of Flash in stable in December, so in 1 month. Some already did, some will do it, I think, early next year.
We should celebrate.
Absolutely. It's a great achievement. And for those who don't know in detail what we're talking about, so Flash has historically been very vulnerable, has introduced many vulnerabilities, since it is often used as a plugin. So it is an external process, or kinda in Chromium, that basically does not play very well with the same origin policy, which is the foundation of web security.
Yeah, so in the beginning there was the web, right? With no security at all. Right. And then people slapped the same origin policy on top of it. Yeah. And Flash decided that was not completely a good idea, so they re-implemented some rules that and basically every difference between the flash protection and same origin policy became a vulnerability. And basically the first directive, object source none, says we're not using plugins, we're not using Java applets, beautiful, we're not using Flash. So basically it tells the browser, if you see someone loading this by any accident, this is not intended. We don't want any plugin to load.
It restricts powerful tags that embed content like object and embed. Usually they're used, as you said, for very, very legacy things like ActiveX or Flash.
ActiveX.
Yeah.
Long time since I last heard this.
It should not be used. Sometimes you can kind of abuse object, because the object you can do more things. Like it can be read by, but still, if you do it and if you have problems adopting a policy with object src none, which completely disallows these tags, you probably have other issues and you should fix your markup in the first place. Yeah.
If you still use object to load images, you might want to switch to the image tag. That is a strong suggestion. Also because we will see in other episodes that there are stuff like fetch metadata that protect stuff, and if you use object, you make it slightly harder to protect. So let's switch to the second, more interesting directive, which is script source. Script source, this one is convoluted. It has 6 components.
Yes, I feel like we should all apologize. Like everyone who has ever worked, in the CSP specification, because CSP started as this umbrella header.
Which, by the way, he is one of them. Just if you want to pick on
someone. I arrived very late and I just contributed a very, very small part of CSP3 together with my colleagues. So this is just to deflect blame, not to
deflect
be modest.
Blame. Okay,
yes,
okay. Right.
Yeah, no, I was saying it started as this very ambitious project. We will stop exfiltration, we will stop everything, and then, every new change had to be backward compatible. So since there is no explicit versioning, so this means that there are keywords that you have to put so that it doesn't break old browsers that just support an earlier version of CSP.
Right. And if you look at this, I have a slide for this. So basically, on modern browsers, what you do is you ignore some of them. So basically, you have the nonce, unsafe eval, and strict dynamic. So to summarize it, scripts have attributes. One of them is src, which everyone uses, of course, to source the script. And then there is one more that you can add, which is nonce. Then the value of the attribute has to be identical to the value that is sent in the HTTP header. And this is a strong security mechanism because, again, an attacker, to inject a script in the page, will need to guess the nonce. And since the nonce, as the name says, is used only once, it is very hard to find a way to add something that will execute actual code. But there is more, because in this case, you see that unsafe inline is crossed, so the unsafe inline directive will not be read by modern browsers, which means that if you have an on-click event handler or on-load, they will not work. Basically, all the scripts that you write and you create have to find the elements in the DOM and attach the event listeners there. Which, well, first, I think is a good coding practice because it allows you to separate code from markup, which in general...
we are past that, right, in JS development, but yeah.
Right, but for example, if you write Angular, modern Angular or modern React, the compiler will take care of that. So you can have an on-click or a click binding with a handler, and when you compile, it will actually do the DOM connection under the curtain, so you don't need to do it manually. And this prevents any kind of injection to run code, almost any kind of injection to run code, because you either have to guess the nonce or inject inside a script, which, well, if you have an injection inside a script, is kind of a lost battle. But that's another thing.
Or if you are just blessing everything, right? So noncing indiscriminately.
Yeah, okay. If you do something like take my response, every response that my server generates, take every script and add a nonce to that.
Right.
Well,
I mean, as companies, security companies, created a middleware to just automatically create the transitive closure of all the scripts and put them in a huge whitelist of script SSC. This is a very wrong way of doing CSP, by the way. I'm pretty sure there will exist some middleware that just randomly nonces all the scripts and just returns them back.
Yeah, of course, because I mean, first I didn't even put whitelist in these slides because it should be deprecated as a term and as a feature. I think that
Still called like that in the...
they're still called like that in the spec. I think that the only benefit of whitelist if you have two CSPs.
Yes.
One with nonces that says only scripts that have a nonce should be able to execute, and another one that says only scripts that are, for example, from my domain are able to execute. And the browser will match both. So only scripts that you own and have a nonce will actually run, which I think is the strictest CSP that you can have. But we usually use it only in very sensitive stuff, and I wouldn't suggest trying to go there first. The first thing that you should be doing is probably this. And the benefit of this is that if an older browser that doesn't support CSP3 sees this header, what they actually see, I might have started a sound accidentally. What they actually see is these. So basically, what they see is unsafe inline, unsafe eval, and a whitelist. Yeah, so people are laughing because probably there was a dramatic moment completely out of context. So
let's say this is Internet Explorer 8.
Yeah, not many browsers have these issues, and I would say that the vast majority of the internet supports CSP3, but there is a minority that will see this header instead. So it will be unsafe inline, unsafe eval, and a whitelist that allows everything, HTTPS, HTTP. So the only thing that is banned here is JavaScript URIs, basically.
Yes, which are actually a pretty prevalent source of XSS, at least in Google vulnerability reports that we receive externally.
Yeah, right. And in last episode, actually, I showed that one of the major bypasses of one of the templates that I wrote and one of the escapes that I wrote was actually using a JavaScript column URI in an href, which is not a script tag. It doesn't look like it needs escaping. It was correctly escaped, but it was a URL that had a schema that was not supported. Actually, last time I said that React doesn't sanitize for this kind of stuff. It doesn't remove the JavaScript scheme, but it actually will do from the next stable version. So there is some progress in this sense.
Yeah, so let's be honest here. I think the right layer in which we should solve this is actually the browser. I mean, I think browser should refuse to execute JavaScript colon in lines, right?
Yeah.
I think we will eventually come to that, but I guess we have so many.
Well, CSP is one way, right? If you set
sure,
CSP,
I mean natively, yeah. They should just remove the JavaScript colon support.
Yes, because
it makes no sense, right?
The only use that I've seen of JavaScript colon something was JavaScript colon void 0, which is beautiful in my opinion, because it basically says this should not be doing nothing, which this should not be doing anything, which.
It was the legacy way of stopping event propagation.
Yes.
So it was a prevent default, basically.
It is prevent default, but it's shorter. And but I've seen so many, so it kind of makes you wonder why would people use JavaScript, and I found it that way. JavaScript scheme is used mainly to stop event propagation.
I've also seen it in some very not very high code quality applications where they just put in PHP or something like that, like JavaScript this dot value equals something.
Oh.
In an on-click.
Well, one other. Yes, this is interesting. One other thing that I've seen is for event handler is like when the on-click handler passes these.
Passes the event, right?
Calls a function with this as an argument. So basically, you can have a handler that handles everything, and depending on what is passed, it decides what to do. There are many ways to do this. I would suggest not to do it this way for maintainability mostly and security. Second. At this point, security is even second. That said, basically with CSP, with the strict CSP that we showed in actually this previous slide, you get some protection. Even if your template doesn't work, even if someone is not using a template in the right moment, you get protection from plugin injection. You get protection from some XSSs. We'll get later to which XSSs it doesn't protect from. You get the fact that basically base URI. Shall we talk about base URI?
Sure, it's a fun edge case.
Yeah, let's talk about base URI. What is base URI, Miki?
So we were very happy about our nonce-only policy. Sometimes even without trust propagation, which is a little bit safer. But
yeah, actually, we should probably expand on that.
Sure. Maybe.
Yeah, one of the directives that we added is that basically, if you add a script with a nonce and that adds a script to the DOM, you don't need to propagate the nonce manually. It will propagate automatically because you already said that you trust that script.
The first one, the parent, right? So it is important because most of the times, especially if you are like a smaller fish, let's say you don't control all the code, and so you load modules that transitively load other scripts, which you don't control.
jQuery.
Most of the module loading. Yeah. Mm-hmm. So it is important that you just have to bless the parent one and not all the children, because that's sometimes impossible. Think of Twitter widgets, for example, or
right.
Yeah, or jQuery. Yeah, jQuery I think became a little better, but so strict dynamic fixes that. Strict dynamic slightly relaxes the security guarantees. So there are, if we want, we can talk about it.
About nonce-only or strict dynamic.
Sure, maybe it's too advanced. I don't know.
Yeah, we can talk about it later. But yeah, absolutely. So basically, you were saying that we were very happy.
Yeah.
There was CSP in Google in many services, and they had nonce-only, which is the strictest that you can have.
Strict, yeah.
And then
we realized that there is a possibility in which. So it's a technique that we call nonce-stealing, which is not particularly precise. Basically, if you have a nonce and you have a relative path as a src, as a source of a script, so you have, let's say, script src/x.js and then correct nonce, so nonce equal correct, right?
Which is reasonable because I mean your own site, so you have like script/static/myscript.js.
Exactly. So if an injection exists before that, and an attacker injects a base tag, base href, https evil.com, basically that means it is a blessed script from evil.com/static.js or xjs.
What happens in that case is that base changes the way the browser interprets relative URLs. Yeah. So basically it prepends the href of the base tag to every relative URL. So you can point any script that has a nonce, because it was nonced by the template, to any arbitrary script on the internet. Feels like a bit like remote code inclusion, remote script inclusion of some sort, because basically you're saying, hey, this code, fetch it from there. Yeah. And this directive, the base URI none, or I've also seen it as self.
Sometimes it's self.
Basically says only, base URI should not be used in that case, so the base tag cannot appear. And if it appears, it has to point to my own domain.
So sometimes some frameworks use base URI as a defense in depth, actually. So they put base href /, which means it's really interesting.
They use the base tag.
Yes, base href / and very early. And you know why? Because basically, only one base tag is allowed per markup.
Oh.
So if there is any other one added by, I don't think they were thinking of an attacker, but they were probably thinking some other component, it will break. So you will notice as a developer.
It kind of works.
Yes. So in that case, you must put self instead of none. But putting self depends what you're hosting on your domain. Do you have like a CDN-like directory, for example? If you do, it's not great. Not for base URI, but for script SRC, right? So self always depends. You have a personal website, it's fine. You are googleapis.com, maybe not.
Yeah, there is always the problem of what is like the origin boundary. Like if you own your domain, if you own your origin, and you know that everything that runs and is served by your origin is trusted, there is no difference between none and self. if instead you might not trust your subdomains or your domain or something in some paths, or maybe it might happen that, for example, I've seen this, you allow users to upload files, and those files are served back. If there is some sort of content type confusion, you might end up with a profile picture being interpreted as a script. So basically, Base URI none is more securer, but you can relax it.
I mean, if you accept user uploads or entrusted uploads, you should use a separate domain. There is no way around. I don't even recommend using a CSP for isolation. You can use other headers if you want. You can do a default source none, which means no active content at all, no content at all, if it's not HTML. But I suggest using what we call a sandbox domain, which is, I don't know, your website, sandbox.com. So it's completely separate from the site.
While this works, there are some issues with that, because if you have like a separate origin for uploaded files, maybe some of them need to be behind authentication. So that requires cookies, and so cookies are usually not sent cross-site if you're using particular browsers or privacy extensions. So yeah, this is always a trade-off. But yeah, I agree on the fact that if you allow people to upload arbitrary data, you should probably use a separate origin. And this is regardless your CSP. At this point, we have one last directive here.
A fancy one.
A fancy one. One of the latest ones. Require trusted types for script. So, at this point, basically if you have a strict CSP with everything we talked about so far and all the templates, you are pretty well protected against, I would say, server-side XSS with the templates and everything, and some server-side injections due to the nonsing, for example, because attackers will need to guess a nonce. And then you're also protected by some DOM-based XSS, so some client-side XSS, because if you have some code that does like my page.innerHTML equals something untrusted, an attacker would still need to guess a script nonce or some way to run some JavaScript code. So this is already, so far, a very good protection, but it might not suffice. So what trusted type adds is the equivalent of what I described in the last episode on server-side templating on the client side. So if we take a look at these. So in these slides, I showed two different ways to do one thing. One way is to do element.innerHTML and something, markup. Or the other way, which is resetting the text content, creating a child element and appending it. So these are two different ways to do the same thing. One is good. One makes us, as security people, shiver when we see it. Assigning markup to what is called a DOM sync, so somewhere where you put stuff, is dangerous. Because if it is a static string, fine. But if it is a string that could somehow be controlled by an attacker, you're basically running arbitrary code in there and creating arbitrary markup. So in these two different scenarios, we have one thing that will stop working if you enable trusted types, and one thing that will keep working. And I think this is important because basically in one case, in the first one in which you use the dangerous sync, trusted types will throw an exception or use the default policy, which I'll get to in a moment. In the other case, you're not using dangerous syncs because you're setting the source of an image. So this covers, I would say, the last bit that the previous policy could not really do because they didn't run it that way. And this kind of protection is supported by frameworks. So this needs buy-in by frameworks. Of course, as you might have thought, this requires you to rewrite part of your JavaScript, which is one of the issues. The same way that strict CSP requires you to remove inline event handlers, trusted types require you to change the way that your framework deals with the DOM. But once you get there, if you enable trusted types, you're quite confident that all the DOM syncs are protected And by protected, I mean these. Basically, if you need to set some markup, you have to create the type first. So you cannot assign just a string in a DOM-sync. You have to create to assign something typed. Can you think about this? JavaScript is getting types.
Yes,
in many things.
Yeah.
Like I'm amazed lately because you see array buffers have types, and now we get trusted types that are used for security. This is good. This is
It's fun because you said, it's really good. Typing is good always, but you also named array buffers, and shared array buffer is something that has other problematics, right?
yeah. I mean, I will have an episode on access leaks.
Okay.
But yeah. So
it's true. We're going towards typed JavaScript.
Yeah, and the more types we get, in this case for security, the better it is.
Yeah.
So in this case, this policy basically allows you to take a string, which is something that is passed, and generate some trusted HTML. Now, please don't use this code. Do not use this code. I just used it as an example, but this is an example of an escaper that you could be using. And it goes further than that. So let's say that you cannot control the entire code that you have. So you cannot really take any string and promote it to a trusted type and set it to a sync. You can create a default policy. A default policy will take any string that gets assigned, for example, to inner HTML, and call your function on it before it gets assigned. So you can sanitize it, you can escape it. So basically, trusted types brings a lot of the server-side logic that we enjoyed for the last 12 good years, plus some. I mean, it's really 25, but broad adoption came late to the client. So now in the browser, we have these policies that can take code that you control and make it much safer, and code that you don't control and try to make it safer. One example of default policy could be that you don't sanitize anything, you keep everything as it is so your application doesn't break, but you console log, hey, you're still using an unsupported DOM sync and you should really refactor this code, because it tells you the sync, it gives you an event that you can work on to refactor your application. So at this point, if you roll out safe templates on the server side, you use a strict CSP, you use trusted types, you're pretty well protected against XSS. Now, CSP doesn't just do XSS, and we'll get to that. But I would say that at this point, you're pretty much done with the XSS protection. This is everything you can do. One more thing that you could do is to add reports to CSP and say if anyone attacks your site, you might get reports. Now, if it is a sloppy attacker, and this sometimes happens, that if it is a sloppy attacker or a penetration tester or someone that is trying to find an XSS in your site, you might get some reports from the browsers. And this might hint that someone is trying to find an XSS in a certain point. Maybe you get there first because you have access to the code, or you know what they're trying to do, or maybe you know them. I mean, it wouldn't be news that people detect an attack thanks to CSP reports. But I think that's about it for XSS. Shall we talk about the other directives for CSP, like style source or image source, or I don't know, frame master source?
Sure. We can focus on all the exotic ones.
Exotic.
What do you want to focus on? Do you have something in mind, or just
style source?
About
Style source.
Style source. Yeah, style source restricts style sheets, both from using a style tag or a link rel style sheet. Some years ago, actually quite some years ago, I think it was probably 6 years ago or something like that, there was this great article by Michael Zaleski, postcards from a post-XSS world, where
he was so optimistic.
It was very optimistic. He said that, XSS is kind of very well understood, so we'll probably get rid of XSS in a couple of years.
Solved.
We will solve it completely. We're not there yet. I mean, a little bit like SQL injections, right? I mean, we do have the solution for SQL injections, but they are still there somehow.
No, they're not there if you don't look at them.
Yeah, exactly. It's interesting because this is another topic. But anyway, we still don't have a solution for XSS, by the way. So we are even further away for all types of XSS. So what I was saying, yeah, and in this article, Zaleski said many nice things. Like, so let's imagine we don't have any more untrusted JavaScript execution. What can we do without JavaScript to still exfiltrate basically content from the DOM to an attacker?
Right.
And then he was saying, CSS, especially the new one, CSS3, has many ways of exfiltrating, both directly and especially indirectly via side channels. Here we can go as deep as we want, but basically the idea is CSS is maybe Turing complete. We don't know if the Conway game of life you can run.
So CSS is Turing complete, but I don't think it is. It has been demonstrated.
I've read demonstrations proofs about both arguments, which is pretty interesting.
Oh, interesting. Might be like PCRE. Might be like it is. It can solve some Turing required problems, but not all of them.
At least I know that the proof of concept in which they implemented the game of life in CSS3 actually had some kind of trick.
Oh, so they limited the limit. Okay,
it was not pure, but anyway.
But yeah, anyway, the best proof of concept that I've seen of these, it was like 2 pages. One that only implemented CSS, no JavaScript, and you moved your mouse on one page, and that would draw your cursor position on the other page, and that was purely with CSS.
Yeah. Which
I find is amazing and chilling at the same time.
Yeah.
And the way it worked is that basically when you focus on an element, you can tell CSS to, I don't know, change the font for that element or do something for that element. And if you change the font or change the background image, for example, that would trigger a request in the browser. The browser would fetch the new image. So if you have a layer, an invisible layer in front of a page, a table, and every time you move on a cell, that actually fetches a new resource, you know where the mouse is. You know what the user is doing. And that is just with style injection. So when you get there, it's not as bad as an XSS because you're not running code, but you're exfiltrating potentially the entire page.
Yeah, there are tools very powerful like selectors, especially CSS3 selectors. Now they became so powerful they can be, they support regexes, they support things that are really, really advanced. And yeah, the idea is that you modify some kind of attribute of the style, and as a side effect, for example, it, changes the size of an element or something, and then you can actually read that size. So by using some kind of bisection, or bisection is very, very raw, you can do more smart things. You can exfiltrate the content of the page. Sometimes it's based on colors, sometimes it's based on size, sometimes it's based on even timings in some cases, even though those are becoming harder to exploit. So
those usually require a big injection though. So like if you inject a style that has that much logic, you either have a big field of injection, in which case, well, you're kind of done. But if it is just a small field and you do a style and you sort like a link and you source an external style, you can use style source to self or to a domain that you trust, and in that case you can kind of limit this kind of injection. Now again, there is a problem that if you're hosted on a domain that is shared across users, using self is not really that good of a protection, especially, or if you whitelist, that is the technical term, a CDN that is like allowing everyone, or like someone that offers powerful endpoints, that is the same.
Yeah.
But style source, I think, is like the last resource of protection. And if you prevent styles injection and you have strict CSP, you have trusted types, at that point you're well protected against injections. I would say that the only thing that is left if you have an injection on the server side inside a script that you nonce, but in that case...
Yes, so if I may add, like the strongest way to protect against style injections, which you should probably not need to care about, is noncing, because they accept nonce. It can be the same nonce of scripts, it's fine. Or even better, if they're static, use hashes. Hashes are very convenient for styles. Usually they do not change. They're cached. So you use hashing and you use SHA-256.
Yeah, but for the hashing, it has to be in the page, right?
Probably.
Can you hash a link?
That's a good question. I would expect at least in Chromium, yes, but maybe there is a limitation in some
because
of the
I
browsers.
remember there were some browsers that misbehaved if you hashed a link.
I think I remember something similar.
Yeah.
It's probably been solved, but you're right.
Okay, well, if that's been solved, fine.
Yeah.
But,
so I'm a fan of hashing.
Yeah,
in
hashing,
general.
of course, because there is no
It's limited.
hash stealing.
Yes.
If hashing basically works the same way of nonces, but instead of just having the right hash, your script actual hash has to match the one in the attribute.
So in particular, I really like something that it's in our slides, Lucas Waxman and mine. I don't know if you put a link.
Not yet.
So it's combining strict dynamic with hash is very, very powerful because you have a bootstrapping script that is static, and it basically contains a list of all the scripts you want to load. Then you have a very simple for loop that just adds to document head the scripts, and basically you just put strict dynamic. So it's just one hash and strict dynamic, and it has. So in our experience, it's even stronger than nonce plus strict dynamic because you don't have the whole non-stealing part of it.
Right.
But it is, of course, there are some limitations. It's
when I write one-page applications,
yes,
like with
exactly.
Angular, etc., I hash the bootstrapping script.
For Angular, it's great.
Yeah, that is amazing because Angular then adds scripts to the DOM, and if you have strict dynamic, you don't care basically because it works, and that is nice. Sadly, there is no strict dynamic for styles.
Yeah.
So if you, I don't
wait,
know.
What do you mean, like transcluding other?
If a script adds a style to the page,
sure. Yes,
even if you have strict dynamic, the style won't
need
load.
to do nonce propagation.
Yeah, exactly. So that is the only problem I can think of.
Yeah.
Adding styles dynamically still feels weird.
Oh, they do.
But
it
happens. I did it.
Oh no, all the widgets do it. I know because I like Twitter widgets, Facebook widgets, they do style dot. Yeah.
So but at the point, if you have a reasonable style source, you have nonces, and the good policy, which I can put here. I would say that one of the ways that you can be owned or that data can be leaked is inject a style or have an injection in a script. Otherwise,
well, you could. There are
there are many ways. Okay, there are many ways. There are access
we
leaks.
We worked for years on here, right? So there are many other ways, right? It could be script gadgets. If you use strict dynamic, especially, which is advanced techniques in.
But you still need a sync.
Well, you need like Ember.js or Polymer or
you need
sometimes even jQuery, old jQuery.
You need a lot of gadgets.
Yes.
And you need an injection.
Yes.
In the first place.
Yes.
And it has to be a quite lousy injection.
I agree. There are many things, limiting factors to the. So, may I say one thing? About the two unsafes there. So you said unsafe inline is ignored, right?
Unsafe inline.
Yeah, yes. By modern browsers. What about unsafe evil? Maybe people are wondering, like, why unsafe there? It's bad unsafe.
So unsafe evil. Evil is bad. It's even in the name because it's evil. But if you wonder about it, there is this tendency of creating code at runtime and then evaluating it at runtime with evil. This happens in some libraries. This happens in some front-end frameworks. This happens in handwritten code. To be honest, this is bad for two reasons. First, performance. If you eval code at runtime, the browser is going to have a hiccup. Like if you write code with evil, the browser is going to stumble across your evil because it cannot pre-process your code, it cannot pre-compile your code until you call evil, which is performance-wise terrible. Second, if there is an injection in anything that is controlled in that string that ends up in evil, you have basically arbitrary code execution because you're telling the browser, run whatever I pass to you. why do we add this to the policy? I'm going to ask you.
Yeah, so historically, we had to add it. And I think, but by the way, I think that nowadays we could get rid of it in most places, I would say.
Most frameworks don't use it anymore.
Most frameworks don't use it, especially externally, I would say. This was also a little bit of an internal problem for our company. But we did have some module loading logic that actually used eval, and we also had some anti-abuse techniques that basically had a virtual machine. And the virtual machines
Let's not
work,
disclose
of course,
too much on internal
no,
details.
there is a public paper I checked.
Oh, okay.
Yes. Without details, of course. But the idea is eval is convenient in these few cases. What eval is not convenient is parsing JSON. Okay, so very recently I talked with a developer in a major company. And he said something that you read sometimes online is that parsing JSON with eval is faster than using JSON parse.
But it's not.
This is absolutely untrue. It used to be like that maybe 4 or 5 years ago, but it is hundreds or even thousands of times faster using JSON parse because it is async. Eval, as I said, is basically an interrupt on your page. So eval, really do not use it. Document write is another interrupt. Do not use it. And by the way, if you use document write, you get a big warning in your dev console right now. We should also get it in eval for eval.
Document write is in the same category of JavaScript URIs. We should get rid of it, like remove it from the platform as soon as possible, because all the uses for it are bad user experience and bad security practices.
Chromium had metrics about this, and it's still very used.
I know, but
it's very sad.
If you're telling me bad UX is on the web, I'm not surprised. But yeah, eval, by the way, is a sync without the A function. So until eval is done executing, your JavaScript stack is stopped. Like the entire word is stopped. You cannot do anything else, which seems silly. Like you might have a user skipping frames because you decide to use eval. So don't be evil.
If you don't need it, remove it. I mean, maybe start without, see if you get eval errors, and if you get eval errors, put it back. You don't relax, to be honest. It depends what is the piece of code that puts eval. If it is just module loading, it's probably vetted, and it's probably okay security-wise, so you probably don't relax it too much by putting unsafe eval. But in general, it's bad code practice. It'll probably make your website faster if you remove it anyway. It's not just security.
Right.
So
it needs to be said that if you don't use eval, if you have unsafe eval, it doesn't relax your policy. Not too much, right?
Yes. Well, maybe an attacker can craft a vector that has, for example, more restricted char set. Maybe.
Oh, right. But it's a very specific case.
Right.
Like if you never pass anything to eval,
absolutely,
having a safe eval doesn't really hurt.
You're right. So yeah, the dangerous thing is actually injecting inside an already existing eval sync. Right. Yeah, like an inner HTML. So even more than HTML.
At this point, I would say let's wrap up. Sure. But before we go, I would like to ask you a question. What's with the random written with a 4 and a 0?
Yes.
Once Miki told me that there was a problem with random, and he observed that some pages had CSP correctly set up, except the random for the nonce was literally random written in lit script.
Yeah, R4 and D0M, which is exactly what Lucas and my colleague Lucas, and I put in our presentations, many presentations about CSP, and I think even in some documentation. So I think some web developers just copy-pasted clearly a placeholder random, right? But no, and basically it was always the same, so it was trivially bypassable because it was always the same. And it was, I think, amusing because it was random, and it was not. So well, it's just amusing for us, but
well, it's like, you know, the XKCD random function return 4. Yes. I roll the dice to write this function.
Well, you cannot falsify that, right?
Yes.
You cannot falsify that.
The fact that it's not falsifiable doesn't mean it's useful.
Let's not get
let's not get there. I think that on that note, I would like to ask the audience if there are any questions. about this. And while the audience thinks about questions, I think we might enjoy our drinks a bit more.
Absolutely. Just some water.
There is a bit of lag between the time I ask for questions, any questions, so I thought.
Oh, I'm sure people had, they were very ready by their keyboard. And
I mean, CSP is a complicated thing, especially considering that is seen as a thing that is hard and
it is complex. It is unnecessarily complex, and it should be made much more simple. I mean, not made. I mean, I think it is beyond hope, right? I mean, like
we should get rid of it.
We should get rid of it. We should just use a subset of it, right? The subset that works against cross-site scripting, without giving false hopes, like using it and against exfiltrations or things like that. But I mean, by any chance, you can use it against, to restrict framing. Absolutely, there are many legitimate use cases.
Well, restrict framing is good. It's one of the few things that it does well.
And does well.
But still,
frame ancestors, it's very powerful, more powerful than X-frame options.
When I was doing penetration tests, sometimes we would find some issues in web applications that we would test, and we would find like they were missing some protection. So we, among others, suggested to use a content security policy. And our suggestion was to add content security policy. We didn't specify which policy, because we expected people receiving the reports to make it up their own. I've seen the best policies, because I mean, CSP is broad. This is why we're making this stream now, to highlight how simple it can be. We have a question, by the way. How simple it can be, how the policy can just be down to 5 directives with some minor configurations. So we have question. Where did you get the awesome sushi t-shirt, Mickey?
Thank you. I don't remember. I think I bought it online, and my girlfriend has a matching one, which is very cute, I think.
Are the sushi rolled on the other side, on hers?
No, I think they are exactly the same, unfortunately. Okay. But I really liked it, this style. I also have another one which is really, really cool. It's like with an infographic and human, and basically all the organs. So it looks like an explanation of like how our body works. It's pretty cool. But I mean, you should probably just Bing, sushi, green sushi sleeping t-shirt, and put this referral code.
Okay, this is not absolutely not an ad. This video is not sponsored. And did you just suggest people to Bing? Do you use Bing as a verb?
Yes, I do. I think Bing is the verb for web searching.
Okay.
Have you considered using a VPN to protect yourself?
Oh God, yes, I have considered it.
Okay.
Sometimes I do use a VPN to protect myself. Yeah. Do we have any other cliches? Like, I don't know, does anyone want to buy some protein shakes?
I wanted to mock the sponsored and promoted videos.
Right. So, yeah, people are suggesting that it's add time. Right, there is some threadless comments.
Yes, it might be threadless. Yeah, I shouldn't have said that, but I think it is.
It is a threadless t-shirt.
Yeah.
So basically it's one single main thread that runs the entire code.
Yeah, it's basically JavaScript or Python.
Right. Amazing.
Yeah.
I think that on the note, we can close. Thanks everyone who synced in, and next time we will have an episode on cross-site request forgery. Thanks, Mickey, for joining me.
Thank you for having me. Thanks, everybody.
Goodbye. There is one question.
No.
There is one question by Maciek. Okay.
Oh, Maciek, our friend Maciek.
Yeah, one of our colleagues. Do you see any new features coming to CSP in the nearest future? Well, we just got trusted types. I mean, how many do you want in a year? This is plenty.
Trusted types is great. Like it's hard not to be excited about the trusted types. It's it is it is very ambitious and it's very focused, right? It's really trying to solve one thing only, which is DOM XSS, which is actually the main XSS, and it is very close to the browser. It's basically hardening the DOM API, right? So it's taking it from another side to
think about it. A CSP directive that does one thing close to the browser. Can you think about it?
Yes, yes. But I mean, if you think about it, like CSP always kinds to do things in a convoluted way. This is much more simple, much more explicit, you know. Anyway, so trusted types, I think, is the feature. So I think there are other people that are more qualified than us probably to answer this, but I think that the consensus in the W3 is we should not overload CSP no longer, not much more than what it is already. So we should actually try to simplify it, and we should try to maybe even, you know, carve out the parts that are useful and make them simpler. So not adding, but you know.
Not adding more parts. I've seen some interesting proposals by, for example, MyQuest, one of the best ones that I've seen, that basically says, okay, let's take what is good in CSP, which is basically what we talked about tonight, that CSP, and just make it basically a Boolean flag. And basically, you set a header in which you say, I want to be protected, and that will automatically enable some parts of CSP, more or less. But I don't see CSP.
So thinking a little more about it, there are a couple new ones, and they are for navigations. But I think they're just proposals, and I don't think they will get.
And they have issues because they introduced some access leaks.
Yes. I think the Navigate 2 is a new one.
Yeah. So basically, will something eventually get added to CSP? Probably,
because it's hard to resist the temptation of having one umbrella header. You know, even trusted types that is so clean, so new. You know, it was convenient for trusted type to use a CSP as a delivery header.
But it was initially proposed as a separate header.
Of course, but it is harder to get adoption, and piggybacking the CSP was.
But so will something eventually be added to CSP? Likely. Yeah. Will it make a big difference? I don't think so. Yeah, because at this point we have a very good set of features, and we should just try to carve those out or just make people use those.
I think what will make the web safer is if all major browsers adopted the latest standard like CSP3, which is we're almost there, but we are still not there. There is one major browser that
the problem is that basically what we talked about tonight, that policy, there is one browser that if you use that, the policy becomes useless.
So it falls back gracefully, so it does not break.
It doesn't break.
It does not protect 100%. Actually, it degrades the security of it, and it is really unfortunate. And if I had to say, you know, one thing that for CSP, I would like to see eventually all major browsers, and we are almost there. We are like all except one. So
yeah, I mean, Edge now supports it.
Absolutely. Well,
Chrome supports it. Firefox supports it. There are a lot of major browsers that people use. Everything that is based on Chromium supports it. So we have a good, nice coverage.
All Chromium based. So it's Edgeium, the new Edge. It's Opera. It is Chromium. It is Chrome. Firefox has good support.
Brave.
Brave is Chromium.
And most of the browsers that we see nowadays use it. So adopt it and implement it. Vivaldi, the browser for hackers. I think that the best improvement that CSP could get would not be another directive, but it would be another browser.
Another browser.
Thanks everyone. Bye.